I'm Sam Dahl, and I'm going to talk today about Newton's third law, which says that for every action there is an opposite and equal reaction. One of the best ways I like to think about this is if we were out in space and could get rid of friction, because friction always tends to throw things off. But let's say we're in the middle of space and there's no friction out there. If you are out there in your spacesuit and you throw a baseball, so here's you in a spacesuit, and you throw a baseball this direction, obviously you have applied a force on that ball and you've made it go in that direction. But the third law says that for every action you take, there is an equal and opposite reaction. So if you apply a force of 50 newtons that direction, the ball also applies a force on you of 50 newtons in the opposite direction. You apply a force on the ball, but the ball also applies a force on you. And it's the same amount of force. That means that when the ball goes flying this way, you will move back that way. So you throw the ball and the ball goes that way and you move like this. Now, because force equals a mass times an acceleration, and the baseball has a pretty small mass, so I'll use a small m there. For that amount of force, it's going to have a fairly large acceleration. Small mass, large acceleration. You, on the other hand, are going to have that exact same force on you, the 50 newtons. But what's your mass like? Your mass is much larger than the ball, so therefore you will have a small acceleration, like that. So the ball will go quickly that way, and you will go slowly this way, but the forces are equal. And in Newton's cradle, you can take these swinging ball bearings here, and if I take one and I let it go, it's going to hit through here. And of course, one will move like that. It creates an action and a reaction on this side that is equal to the other. That ball swings this way and hits back. You have one going back and forth, back and forth. If I take two, like this, and let go, I have an equal reaction this way, which makes two move back and forth. And if I take three, what do I get? Should be an equal and opposite reaction. But wait, there's only two over here. So watch. The middle one transfers over so that it's three both times on each side. And this one's fun. If I do 2 and 1, they switch which side they're on. 2 and 1. Or 3 and 1. Etc. So that is Newton's third law.